Welcome to Session 22. Select models from tables and graphs. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to identify linear, quadratic, and exponential patterns from tables, to interpret model parameters and residuals in context, and to distinguish interpolation from riskier extrapolation. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. A trend model summarizes structure. Residuals measure observations' vertical departures. Look at shape before individual points. A useful model leaves residuals scattered around zero without a systematic curve. Residual structure suggests a different model. The key distinction is this: identify linear, quadratic, and exponential patterns from tables. Then connect it to the second goal. Interpret model parameters and residuals in context. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Confirm input intervals are equal before comparing differences. Identify the object being changed and the requested result. Step 2. Test first differences, second differences, and ratios. Use a separate line so signs, units, and restrictions stay visible. Step 3. Write a model and verify it against more than one point. Work efficiently without skipping an operation. Step 4. Interpret parameters, prediction range, and residual sign. Whenever possible, verify with evidence independent of the original working. Signal 1 is constant first difference. Respond by remembering. Choose a linear model. Name the response before calculating. Signal 2 is constant second difference. In that case, choose a quadratic model. The form tells you which tool fits. Signal 3 is constant ratio. Remember, choose an exponential model. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. For x equals 0, 1, 2, 3, a table gives y equals 5, 10, 20, 40. Choose a model and predict y at x equals 5. Restate the target and identify the most important part of the routine. The first move is, outputs have constant ratio 2, so the model is exponential. This changes the form without changing the meaning. Next, because y equals 5 at x equals 0, use y equals 5 2 to the power x. Keep the relationship visible and apply the operation to every required term. Now, audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. At x equals 5, y equals 5, 2 to the power 5 equals 160. State what the transformed line tells you. Complete the argument. The x equals 4 value would be 80, confirming the pattern. This is part of the solution, not decoration. The final answer is y equals 5, 2 to the power x with y 5 equals 160. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. Observed is 31 and predicted is 35. What is the residual? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. A focused hint. Residual equals observed minus predicted. Use it to repair your setup rather than guess. An accepted answer is -4. Explain why it works and name the first step that would expose a common error. The central message is, identify linear, quadratic, and exponential patterns from tables. Combine it with the discipline to interpret model parameters and residuals in context. Finish by remembering to distinguish interpolation from riskier extrapolation. This turns a calculated result into a justified answer. Reflection. Why is a constant output increase different from a constant percent increase? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 5 minutes, including verification at 2 points. Keep the work readable, check it independently, and carry the routine forward.